Hi, we're going to make a frequency table and histogram using the cigarette data from 1960. So if you open that Excel file, which is on Campus Cruiser, then the first sheet looks like this. It describes the different variables and what they mean. There's a reference for the data set, both on the internet and then also a reference from the journal where this data set came from. So I'm going to use, for this exercise, I'm going to use the lung cancer data. And this lung cancer data, again, it's from 1960, and this was the incidence of lung cancer from each of the states, each of the 43 states. So it was the number of deaths per 100,000 from lung cancer from each of the 43 states they have data on. So I'm going to first, like before, because I want the first sheet to just stay clean, I'm going to make a copy of this data and create a new sheet and paste the data there. Now to make a histogram and to make a frequency table, well, let's start with the frequency table. To make a frequency table, we need classes, and then from the classes, we would count, if you're doing it by hand, you would count the number of data values that fall in each of the different classes. Well, with Excel, I'm going to have Excel, Excel will do much of that automatically. But certain things it's not going to do automatically. So what we need to do here is first start with a width. We need to decide what's the width of the classes. Now, you might remember from last time. Oh, oops, that was my cell phone, which I should probably turn off. Okay, I'm turning off my phone. You should maybe, perhaps, hopefully remember from last time we had made the descriptive statistics, and when we did that, among the things we found were the min and the max. So the largest value here is about a little more than 27, and the min is about 12. Okay, so hopefully you recall from the lecture on frequency tables that the width of the classes, the width is equal to, in general, what it's going to be equal to is the max minus the min divided by the number of classes that you have for your table, number of classes. So that's generally, how you're going to figure this out. So for this particular case, what's the max? The max, so I can do this little calculation now in Excel. To do a calculation in Excel, you would start any formula or calculation with an equal sign. So this is going to be equal to the max. The maximum for a lung is 27.27. So this is going to be 27.27, and subtract, and then subtract the min, which is 12.01. I don't really need that level of detail, but I put it in anyway, and then divide that by the number of classes. So how many classes do we want? Well, in general, the number of classes should be anywhere between, say, 5 and 13, depending on how much data that you have. This data set has 43 values. We can see that, or 44. I was remembering 43 states, but I think District of Columbia also has a data point in this set. So there's 44 values. N is 44. That's the sample size. So how many classes do I want here? Well, that's not a lot of data, so I'll just ask for five classes. So what would I get if I did that? That would mean the width would be this number. Okay, let me minimize that. So the width is about 3. Okay. So to create the frequency table in Excel, Excel uses things called bins, and bins function as the upper class limits or boundaries for the frequency tables. Now, if my width is 3, I want the first upper class limit to be larger than the minimum in the data set, and we know the minimum in this data set is about 12. So what I did in the lab was I used 13, and I'll be consistent with the lab that you have. So I'll start at 13, but I could have started at another number. I could have started, well, I want it to be larger than the min, and the min is 12. So I could have started at 13, 14, or even 15. That would have been the minimum plus 1 width is would be 12 plus 3 is 15. So I could even start this bin with the upper class limit of 15. If I want to be consistent with the lab, I'll use 13, so I'll start with that one. Okay, so that one's 13. So what's the next bin? Well, the next bin is going to be equal to the previous bin value, and then plus the width. Now the width, I'm not going to use the decimal value. You want your width number to be a simple number, so I'll just use 3. So 3 and 16. Now I need to repeat this, and Excel will repeat this algorithm automatically. If you highlight the cell and wait for the plus sign to appear, it will continue adding 3 to previous cell values. So I'm up to 28. 28, what was the maximum? 27.27? Was that what it was? So that should be, yeah, the maximum is 27. So here I can stop at 28 because 27.27 will be in this last bin. And these are, again, these are like the upper class limits for the classes. Okay, so once you have the upper class limits, the bins identified, then we can use Excel to do the frequency table. So to do that, you can go to data and then data analysis. Now, by the way, oh, I think I showed you in the last video, if you don't have data analysis, you know, how you can load that into Excel. So if you don't have that and you're not sure what to do, please look at the previous, the earlier video that I made on descriptive statistics. Okay, so we'll go to data analysis, and what we want to do here is histogram. So if we select histogram, then this dialog box comes up and we need to identify the input range. Now the input range is where the data resides on the spreadsheet. So I'm going to click on the red arrow, I'm going to highlight the data, and by highlighting the data it will put the syntax for these cells into Excel. Those cells are A1 to A45. Now the next piece of this box I want to fill out is the bin range. We just figured out what the bins are. So again, I'll click on the red arrow and highlight the bins. Okay. Now in each case, the first line that I included has text in it, and it's important that well, a few things are important. One thing that's important is that we're consistent. If you included the text in your variable name with your data, you need to do it with the bins as well. So I included the word lung with my data. I also included the word bins with the bin values. So I do have labels, in other words, text, in the first location for these in these ranges. Okay, so I'm going to click on that labels box, and in terms of what I want, I'm going to identify my output range. The output range for the output from this little program, I'm going to put it here. I'll start it there. I don't want it in a new sheet. And I also want chart output, so I will get a histogram from this. Okay, so if you look on your lab, what have we done? We did all of this stuff. We did input range, we did bin range, we collected on the red arrows, we did all this stuff. So if we click OK, then the frequency table is here. Okay, and then the histogram is also here. It's going to need some fixing, but the rudimentary histogram is here. Now, one thing we can notice by looking at this is we have a category called more, and more contains nothing. This wouldn't be empty if this upper class limit was less than the maximum. since we made it so that this upper class limit was larger than our maximum, there is no data values larger than this one, so this category is not needed. So we're going to delete it. So if you highlight more in the cell to the right and you right click on that, then you can go to delete, and shift cells left will work. So that will make it go away in your histogram as well. Now this legend serves no purpose, so we're going to delete it. And so what we have now is a histogram that sort of needs to be fixed up to make it look like a histogram. So to make this look more like a histogram, the first thing I'm going to do is right click on the bars, and I'm going to go to Format Data Series. So if you go to Format Data Series, you can change the gap width. Right now it's 150%. If you make the gap width 0, then this will have the appearance of a histogram, which is there's no gaps, because this is a continuous, supposed to represent a continuous scale. Okay, so we have that, and so we've done everything on this page of the lab. And so our next thing to do is to finish the chart and make the chart, reasonable, a good chart. And what does a good chart have? Good charts have titles that are descriptive, that tell you something about the data set. So, or tell you something about what the data is, what the chart is we're looking at. So this is the number of deaths per 100,000 from lung cancer. Oops, I'll have to fix that. US, and I'll just have 1960. Okay, now the size of this title is really too big relative to the chart size, so I am going to, reformat that so it just doesn't take over the way it did there. And do I want to get rid of the bolding? Perhaps. No, maybe I'll keep that because this is now a style thing. It's whatever you like. Now the bins, these are this scale here. This was really the number of deaths per 100,000. These are the values for the lung variable. So this is the number of deaths per 100,000, and this axis really is frequency. Okay, so this is the histogram, and it gives us an idea of the shape of the distribution of data. We can see that the maximum frequency here, this range has an upper class limit of 22, and the mean was a little bit less than 20. The mean's a little bit less than 20, so the mean's over here, because these values over here are pulling the mean down a bit. It has a little bit of a left skew to it. And so this is our histogram. Now, so for this histogram, if you select the chart and you do whoops, that's not what I wanted. If you select this chart and do a Control-C, then with your Word document open, you can insert your chart. And what does my chart look like? So my chart is here. I can center, justify that. I can get rid of the border if I want. Let's see, no line. So it looks like the line is still there, but could be when it prints it's not there. I'm not really sure. But so here it is, and that's how you can make a histogram in Excel. Okay, next we'll make some of the other charts, and those will be in new videos.